Hello everyone. I'm Andy from ThinkMo. I am currently teaching CCIE courses. From today on, I'm going to share with you CCNA, CCNP, CCIE related technologies. Our topic today is: how does ISIS quickly generate LSP? Accelerate network convergence. In the process, it relates to the interval for ISIS to generate LSP. So we have to ask the corresponding question. First of all, why generate LSP quickly? Let's explain LSP first. LSP indicates the ISIS routing protocol, a packet used to transmit link state information. It's a message. It is also an LSP that carries routing information. In short, that IS in the ISIS network. Routes are transmitted through LSP. This means that the routing information is generated faster. The faster you can deliver it, the earlier it is produced, the faster it is transmitted. The condition of being able to pass is based on when is it produced. So you get the idea. Why do LSP need to be generated quickly? It is related to the convergence rate of network. We can take a look. There are two routers. These are router 1 and router 2. Let's say path 1 advertises a route to 1.1.1.132. Or a route is deleted. In this case, LSP are generated. It was produced after. I'm sure it'll be sent to someone else. Neighbor router. However, the newly generated LSP, in the process of producing, the generation time is in seconds. Cannot meet carrier class requirements. For some large networks, like inside the data center or the carrier's network, it has high requirements on services, especially things like finance. Securities class these networks. If the convergence time is seconds, it's too slow. So it's basically sub-second. Once something goes wrong, it has to be detected in a flash. Implement switching or backup. This convergence is what we call carrier level. Because the production time is too slow. It's like we make things. The production time is too slow. You may miss the opportunity. So we have to do it in a corresponding way. Let's make it a little faster. For example, forcing it to generate LSP quickly. The following paragraph will explain. If the time for generating an LSP is too fast, it can also cause problems. Let's say the link is down. It's not a one-time glitch. It may be continuous and unbroken. This is what we call jitter, or the oscillation. Like some modules of optical fiber. Or because of the quality of the line, it goes up and down. In this case, either the advertising route or delete the route all generate LSP. If the time for generating LSP is short, the route is now advertised. It's not going to be delivered anytime soon. It takes a fast time to generate LSP. But if the link fails again, whether an LSP is also generated. So for this or one device, it's a huge drain on resources. For example, for its CPU or memory. There are considerations involved. Because it has to compute. It's been up and down. Continuous LSP generation. There are certain tests on performance of this equipment. At this time, we are on interval of generating LSP. Improvements have been made accordingly. It is an intelligent timer that generates LSP interval. We can take a look. This is a configuration command. It is an intelligent timer used to configure LSP generation. It has its parameters described here. This command can be followed by 3 times. The first one is the maximum delay time. There is also the delay for generating LSP for the first time. Then, two LSP with the same LSP ID are generated. Incremental delay time between. The increment time is followed by milliseconds. These three times can be very good solution. In addition, LSP can be generated quickly. It also minimizes the resource consumption of the device. Reduce the number of LSP generated. Or the oscillation of the link. Consumption of device resources. How does that happen? There's a couple of times here. The first, max interval. Maximum delay time. It specifies these LSP. If only the max time is configured. The timeout is how long it takes to produce. But obviously, the maximum delay time cannot be applied flexibly. So there's the init initialization time. Let's say this link is down. First departure. That's when the first trigger happens. And then there's the incremental delay time. Let's say it goes off the network for the first time. Now the link has resumed the second trigger. There are corresponding instructions here. It means that two productions are the same. LSP ID indicates the increment delay between LSP. When it's produced the second time, its time is the configuration time. For example, set the maximum time to 10 seconds. The initialization time is set to 2. Then the increment time is set to 3. First init the time is the delay of the first LSP. It takes 2 seconds to generate. The second one is going to be generated after 3 seconds. There are some special cases here. First of all, if you just use time. Let's make it a regular one-time trigger. Let's say the configured time is 10 seconds. It's disposable if both times are configured at the same time. The first time is the initialization time. The second time is the incremental delay time. If you change it after 2 times, link rejitter. Every time you change it, you multiply it by 2. Until after the maximum time 10 is reached. Then it goes back to the initialization time. Let's start at the beginning. This is the interval of LSP that you need to pay attention to. In this way, the LSP generation process is solved. The problem of device resource consumption. Secondly, it also speeds up convergence of the network. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.